Something is out there. Voyager 1, the most distant probe ever sent by humanity, has just detected a mysterious anomaly at the very edge of our solar system, something inexplicable, something that shouldn't even exist. Is it a simple malfunction, an undiscovered cosmic event, or could it be the ultimate proof that we are not alone? Stay tuned, because this latest discovery could be the first undeniable sign of an alien presence. Since its launch in the late 1970s, Voyager 1 had one primary mission: to explore the outer planets before venturing into the unknown beyond our solar system. It soared past Jupiter, capturing unprecedented footage of its violent storms, then continued to Saturn, delivering breathtaking images of its iconic rings. But it didn't stop there. By 2012, Voyager 1 had crossed the heliopause, the invisible boundary where the sun's influence gives way to interstellar space. That was already a groundbreaking achievement. But now, over 4 decades after launch, it has stumbled upon something so strange that even the most experienced scientists are at a loss for an explanation. Before we dive in, it's undeniable, Voyager 1's latest discovery is far more astonishing than anyone anticipated. And this is just the beginning. The heliopause acts as an invisible barrier, shielding our solar system from most high-energy cosmic rays and deep space particles. But something unexpected is happening at this boundary. Voyager 1 has detected strange vibrations in the magnetic field, anomalies that simply shouldn't exist. These waves are rippling through space in ways that defy all previous predictions. The data doesn't add up. Scientists long believed this region would be relatively calm, with only minor fluctuations in the magnetic field. Yet, Voyager 1's instruments are telling a different story, one that hints at an unknown force pushing back against the very edge of our solar system. What's behind these mysterious ripples? That's the million-dollar question. Some researchers speculate it could be a completely new form of energy, an interaction between the solar wind and an unidentified force lurking in interstellar space. Others suggest it might be signals from deep within the Milky Way, echoes of something massive and powerful moving in the cosmic distance. But some of the most intriguing theories take things to an even more unsettling level. What if something, or someone, is trying to reach us? Could these mysterious signals be evidence that our solar system is being influenced by forces beyond our current understanding? Voyager 1's data reveals something unexpected, an unexplained pressure at the boundary of our solar system, as if the heliopause itself is being compressed. Could this be the result of powerful stellar winds from nearby stars? Or is there a much larger, unseen force pressing against us? Some speculate that these ripples could be massive energy currents flowing through the galaxy, possibly even originating from beyond the Milky Way. If true, this could revolutionize our understanding of how energy moves through space. But here's the truly mind-bending part: these fluctuations aren't random. They follow a pattern, something structured and repeating. Whatever is happening out there isn't just chaotic, it follows rules we have yet to comprehend. Is it possible that the heliopause is acting like an antenna, picking up signals from an unknown source far beyond our reach? If so, who, or what, is sending them? Could we be unknowingly tuning into an ancient interstellar conversation that has been unfolding for billions of years? Some scientists suggest that Voyager may first be detecting a vast, unknown energy network spanning the galaxy. If true, this discovery could be revolutionary, an invisible force connecting solar systems and possibly influencing the movement of stars and planets in deep space. This would mean that our solar system isn't adrift in isolation but is instead linked to something far greater than we ever imagined. Voyager 1 wasn't just transmitting data, it was revealing that space is far more dynamic than we once believed. Picture space not as a barren void, but as a vast, intricate web of unseen forces stretching across the galaxy, hidden bridges between stars. These energy currents might be transmitting signals, weaving solar systems together in ways beyond our understanding. If this theory holds, then our knowledge of space barely scratches the surface. The notion that the universe operates on a concealed framework of interconnected energy flows sounds like science fiction, but what if, just maybe, it's the very foundation of reality? And if that's true, then this satellite's decades-long mission might be far more significant than we ever imagined. Launched in the late 1970s, it was never expected to endure this long. Built with technology that now seems like a relic of the past, it continues to push forward, still transmitting signals back to Earth. It has ventured farther than any human-made object, crossing the boundary where our solar system meets the vast expanse of the galaxy, delivering data that leaves scientists both puzzled and fascinated. How can such an aging spacecraft uncover mysteries we never even thought to explore? More than 14 billion miles away, it continues its quiet transmissions, offering glimpses into the unknown. Every signal it sends feels like a whisper from the edge of existence, hinting at a reality we have yet to comprehend. We thought we understood space, but maybe we're only just beginning. We once believed we had mapped the outer limits of our solar system, but this satellite's discoveries keep challenging everything we thought we knew. Mysterious signals, unexplained forces, and strange interactions at the solar system's edge continue to defy our understanding. And then comes the bigger question: what truly lies beyond? If these energy currents are real, could they be evidence of something more? Something intelligent? Something observing us? For centuries, we've wondered whether we're alone, and with each new discovery, that question grows louder. This satellite has already shattered the boundaries we assumed were fixed. But what if it has been sending us clues all along, ones we simply haven't learned to decipher yet? Voyager 2 embarked on an even more ambitious journey, venturing farther and exploring planets no spacecraft had observed up close before. Launched in late summer 1977, it was designed to push boundaries, travel greater distances, and capture more than its twin, Voyager 1. Unlike its counterpart, which swiftly passed Jupiter and Saturn before heading into deep space, Voyager 2 took a more scenic path. Its trajectory allowed it to visit not only Jupiter and Saturn but also Uranus and Neptune, planets Voyager 1 never approached. This incredible mission was made possible by a rare planetary alignment, enabling the spacecraft to use each planet's gravity as a slingshot, propelling it from one world to the next like a cosmic highway. With strategic modifications and upgrades, Voyager 2 was primed to make history. What set Voyager 2 apart wasn't just where it was going but also how it was built to handle the trip. Its cameras had to be adjusted to deal with the dim light around the ice giants Uranus and Neptune. Scientists figured out new ways to keep those cameras steady during long exposures, ensuring the images came out clear instead of blurry streaks. To send data back to Earth from billions of miles away, engineers developed smarter data compression methods, making every bit of information count. The power supply was another big challenge. Since solar panels wouldn't work that far from the sun, Voyager 2 relied on nuclear power. But even that had limits. To stretch the mission as long as possible, NASA planned out a strict schedule for running the instruments, shutting some down to save energy and keep the spacecraft alive for decades. The mission's first major destination was Jupiter, the largest planet in our solar system. Voyager 2 captured breathtaking images of swirling storms, powerful lightning strikes, and the iconic Great Red Spot. It also observed Jupiter's moons up close, uncovering active volcanoes on Io, icy oceans on Europa, and other unexpected, strange landscapes. Next, the spacecraft reached Saturn, providing a detailed view of its intricate ring system and its largest moon, Titan. However, unlike Voyager 1, which concentrated on Titan, Voyager 2 continued its journey toward the more distant, lesser-known planets on the outskirts of the solar system. In early 1986, Voyager 2 became the first and only spacecraft to fly past Uranus. What it found was a planet that looked eerily smooth and featureless, a pale blue-green world with hardly any visible cloud formations. But there was more going on than met the eye. The spacecraft detected a strangely tilted magnetic field, meaning the planet's interior was likely structured in a way scientists hadn't imagined. It also discovered 10 new moons and 2 faint rings that had never been seen before. This flyby alone made Voyager 2's mission a groundbreaking success, but there was still one more stop to make. In the summer of 1989, 3 years later, Voyager 2 reached Neptune, a planet that proved to be far more dynamic than Uranus. The spacecraft discovered the Great Dark Spot, a colossal storm the size of Earth, raging across Neptune's deep blue atmosphere. The winds on Neptune were the fastest ever recorded in the solar system, reaching speeds powerful enough to tear apart anything in their path. Voyager 2 also identified additional moons and confirmed the presence of thin, irregular rings orbiting the planet. Perhaps the most astonishing revelation was that Neptune emitted more heat than it received from the Sun, suggesting that something deep within the planet was generating energy. After completing its grand tour, Voyager 2 kept going.